Okay, welcome fourth graders here to another video test review. Today we're going to be talking about magnets. So hopefully you were at home, you're reviewing, or maybe you have your iPod Touch and you're in your car heading somewhere with the family and you thought you'd get a little extra review. Whatever the case may be, we are talking about magnets. Now, what is a magnet? Oh, by the way, it is college day. That's why I'm sporting some of this gear. A magnet is any object with magnetic force. Okay? Magnetic force is the force that pushes or pulls magnets. Right off the bat, you should also know that the strongest magnetic force is found at the poles of a magnet. Basically at the ends. In your notes, the dotted lines means where the magnetic force is the strongest. And that's at the poles. Okay, at the very North Pole and at the very South Pole, the magnetic force is going to be the strongest. You can see that here, most of the magnetic force is found at the poles. Okay, opposites attract in magnets. So if you bring the North Pole close to the South Pole, they are going to attract. They're going to pull together. Okay. If you bring two like magnets together, they are going to push apart or repel. Okay? So attract or come together, and this is a pushing or a repelling that's going on when you have like poles coming together. How does something become a magnet? Well, in pieces of metal, you have tiny properties, and in the properties, you have little mini magnets, basically. Okay, so these properties inside of metal are like mini magnets. And they are pushing and pulling in all different directions. Okay? As soon as you take this piece of metal that has the properties that are made up of little teeny magnets, and you bring it up to a permanent magnet is a magnet that will always be a magnet. So you bring this piece of metal up to a permanent magnet. All of the north poles are going to be the north and south poles are going to be lined up in the same direction. So you can see they're scattered all over the place, pushing and repelling, and kind of balancing each other out. Whereas once you bring it to a permanent magnet, they're all facing the same direction. Because this is what I did when I was teaching the kids. So all the norths go, oh, there's the south. I held that a little bit longer just to be awkward. Okay? So all of the norths become attracted. Now as you can see, because all of the norths are facing the same direction, it has become a magnet now. It's going to be attracted to an S. Whereas in this one, because they're all over the place, they're pushing and pulling in all different directions, it's not going to be attracted to anything because it's balancing each other out. Whereas in this one, now that all the norths are facing the same direction, it's going to attract an S, or push apart an N. Okay? Now, once you remove the permanent magnet, it sometimes goes back to a non-magnet, because then the properties become scattered again. Sometimes, though, when you remove the permanent magnet, the properties inside the metal stay lined up, and it becomes a permanent magnet. Okay? Magnets that are not permanent are called temporary magnets, meaning they are a magnet, but they can lose their magnetism. All right? Let's see here. A compass is basically like a mini magnet. So you can see the little mini magnet floats on water or whatnot, and it's going to be pointing towards the North Pole. Okay? So you can see the magnet, it's going to be pointing towards the North Pole. Our Earth is like a big magnet. At the very center of the Earth is a piece of metal. So inside the very middle of Earth is liquid metal. So it's basically one of these inside the Earth, except it's liquid. Okay? Now all of the properties are lined up. All of the north ones are facing in the same direction, and all of the south ones are faced in the same direction. So it creates a north and a south pole. And there's, of course, a magnetic field that goes all the way around. A magnetic field is an area of magnetic force. Okay? What's cool about magnets is they don't have to actually touch the object to be able to influence it. As long as it's metal or whatnot, as soon as it enters into the magnetic field, it can pull or repel the object, okay, without actually touching it. Okay. Let's see if there's anything else I need to cover. North and south poles, permanent, temporary, pushing, repelling. I think that's it. So, hope you've enjoyed this video test review. Feel free to ask me any questions on Emoto, Facebook. I look forward to seeing you guys in class.